Yo, what's up, YouTube? I'm back again. Hopefully everybody's right. So what I'm going to do is add on one last problem to our sessions here. I've actually pre-solved it on the screen. So let's just back up a second again and look at the problem. So we have an octagon on the screen, and we're going to start out by looking at the illustration. Uh, the height and width, if you will, of the whole octagon, as if it was a rectangle, is 28 on both sides. So if we were, for instance, to draw a rectangle here around the whole thing, that's the dimension they're talking about there. Okay, and the 11.6 is the length of a side. So there's 8 sides that are 11.6. They're putting a dotted subshapes in here, so we could see that shape A is a trapezoid. In fact, I can even maybe see D. We could do something like D and even the E down here. Okay, and let me even go further than that. Let's call this F. This is G. I know what the question is already, so I'm adding these in G, H, and I. Okay, there's a whole bunch of subshapes in here. So A is an entity, the whole A plus D is a trapezoid, let's put it that way. And E plus B is a trapezoid. And D and E are triangles, right? So there's a couple ways. So they're asking us to compute the area to the nearest square centimeter. So this is already kind of a heads up that we probably are not going to get the area exact, and we're going to have to try to pick from the answer choices. I don't want to scroll the screen because I have stuff written and stuff already. So let's make believe this is a grid in, and then let's see if our answers match, which is one way to solve problems anyway. You shouldn't always depend on the multiple choice answers to guide you. You should still, do it free form because that's proving your mastery. All right, so let me see if I got all this right. So the area of a so what we want to do, the octagon contains 8 congruent sides, so they're all 11.6. The given measures of the octagon are rounded to the nearest tenth. So it's telling you already, right, that this 11.6 is already rounded. It's telling you that the 8.2 is rounded. It's telling you that the 28 is rounded. And by the way, the 8.2 is the height of that trapezoid, if you will, when you look at the dotted lines and so on or whatever there, right? Okay. So what we're going to do is just straight up, we're going to add this trapezoid here. Let's call A plus D. This is T1. I'm going to write it on the dashed lines. Okay. We're going to figure out what the area of that trapezoid is. If we can do that, that's the same area as the second trapezoid. Okay. And then if we can get the both of those, all we have to do is come back and add the area of C to it. All right. So the area of a trapezoid is its bases added together. So we're here right now. Okay. It's its bases added together. Let me make sure we're live, by the way, before I get too ahead of myself. Yeah, it's the bases added together. Give me 1 second to make sure I'm not talking to the wall. Although talking to the wall isn't too bad. Yeah, okay, we're good. All right. So where was I? So we're going to add the two bases, divide by 2, and multiply by the height. 8.2 is the height. The one base is 11.6. The other base is the dashed line there, the long dashed line. I'm going to write over it in a different color right now. It's this line right now. In the green, that's the second base. So that we know is 28. Okay? So that's how we're going to come down to this line now here. We're going to add the two bases to 28 plus 11.6 divided by 2 times the height. That's the height. Okay? So then we're going to get that. That's 39.6 divided by 2 times that. And then this together becomes 19.8 times that. And then we get 162.36 as the area of trapezoid 1. Since there's 2 trapezoids, we're going to multiply it by 2 and get 324 That's 7.2 out of it, okay? All right, so at this point, I'll shade it. Whoops, let me use a different color. We've basically computed that, right, plus that. All right? So what we need to do now is figure out the area of C. Well, we know the length of a side, which is here, is 11.8. And we also know the length of the dash thing is 28. Sorry, I said 11.8. It's 11.6. So all we need to do now, give 1 second, the software is doing, okay. We need to come in and do this computation here to figure out the area of that rectangle C. Okay, when we do that, we get 324.8. And then all we have to do is add the double ones that we did here, the two trapezoids, plus the rectangle, and we get 649.52, right? And that brings us to 650, which turns out to be, I think, was the answer. Right, the answer was C. So if we look at the choices now, we can do that. Okay, there's other ways to solve this, including involving this putting together of shapes, if you will. Okay, we can also use formulas. Okay, there's a specific formula if we come to this number 1 right here. Okay, it's 8 times the number of sides times what's called the apothem, and the apothem is the center to here over to here. Okay, that's by definition something from the origin to the midpoint of the side. Okay, so if the whole length over here was 28, okay, that means this is 14. All right, and it's asking us to do that divided by 2, so we get 7. Okay, so all we have to do is 8 becomes 8. The side we know is 11.6, and if we do that multiplication, we get 649.6, which also points at the 650. Okay, there's another kind of conceptual way to solve this, which is if you take this square I drew here in the orange right here, right? I drew an outer square around here, including all the shapes. If we get the area of that whole square, that's 28 by 28. That's 784 then, okay? And then if we subtract off of it the triangles, this F, let me change the color of that. Do it red, orange, red, green. That's green. If we now take off each of these green triangles, okay? Now we could say 2 of the triangles together is one of the squares. So that's what I'm doing here. We're going to take the main square and subtract off the corner triangles. Okay? Okay, we know the 4 triangles become 2 squares. So all we need to do is remove 2 squares. Okay? So we have the area of the square is 8.2 times 8.2, and we just need to double that. All right? So now we have 784 minus that, and look, we get the 649.52 again. All right? So some of this requires kind of being shrewd and knowing maybe this formula over here. Okay? Others are just using logic and using composite shapes. This is a good strategy often is to kind of take the super shape and remove the parts out of it, and whatever you're left with is the hexagon. I mean, the octagon, sorry. And the other is to use composite shapes and build them up from scratch. So number 2 was using the composite shapes and removing. Let's call this 3 over here, is building up the composite shape, all right? And there's other ways we can view this as well. We could have joined the bottom here and realized that each of these was actually a 28 times 8.2, right? If we take the whole rectangle here, as if I'm going to circle it, as this whole thing was a shape, there's a rectangle there. That's 28 by 8.2, right? And we have another one underneath there that's the same. Okay, so we could have done that, which is similar to what I did, but we still have the issue of these sides things in here. But we know that what's inside of here, if we look at that edge by itself, imagine we're just taking the upper corner there. Up. Whoops, that came out wrong. Let's ignore that. If we had it like this, that upper corner there looks like that. That's a square, and each side is 8.2 times 8.2. So we know that this unshaded part that was originally not even part of the illustration, we know that that is 1/2 BH. Well, the base and the height is 8.2 each, and half of it. So we can actually compute that and subtract that off of the 2 green circle areas I did. And we still need to compute C either way. So we're still good that way as well. All right? And that's yet another way to do it. All right? So that's the last question. Yay! We're finally done with doing all these problems. I hope you guys liked it. Again, please like, subscribe, smash the daylights out of the button. And I'm going to probably start doing SHSAT stuff, maybe even later tonight, maybe tomorrow. We have to see what my schedule is. It's all over the place. I have new students popping up, and I have old students asking for extra classes, extra hours. Everybody wants to change the stuff. Thanksgiving's coming up. The SAT is coming up. Yeah. So everybody just, we'll get through it. And I will probably start doing the cover-to-cover review very soon. And hopefully we can get through it because the days are running out. My time is limited. All right, guys. Peace.